So the Wham Bam Mutant here is comprised of a few different pieces. I mean, the main box has a bunch of pieces in it. And then to accompany that, there's a selection of brackets depending on what kind of a system you're trying to mount it to. So today we're going to be mounting it on the Ender 3 version 2 here. And so we'll use that appropriate bracket, but we'll get to that in a sec. Let's unpackage the main Mutant box. As you see here, this is the V2 of the Mutant. So I'm not exactly sure what's changed between V1 and V2, but just keep that in mind when you're watching this video. So the main component of the Mutant is what you see here. Two parts. This part gets attached to the X carriage and stays stationary on the printer. Your wire loom here with all your connections is going to connect in the top here. And then that leads to these pins, these spring-loaded pins, that then connect those wires up to these leads at the top. So this would allow you to mount your hot end and all the electronics related to it to this bracket here and quickly slide it on with this little dovetail joint on the bottom. Slide that on, lock it in place, and now you've just swapped the tool head on your printer. And you know, if you were running multiple different tool heads for whatever reasons, or you got a clog or a jam or some sort of malfunction and you just wanted to swap it out real quick and you had a spare on hand, you could just slap the other one on and then work on the other hot end off the printer. There's a few use cases that come to mind where this would be pretty cool. So that's the kind of the two pieces. This kit here comes with 3 of these tool brackets, these tool head brackets, and then like I said, the one stationary that gets mounted to the machine. Other components in this bag is some, they call it fixed plate accessories. They call this the fixed plate, right? So this has some wire loom and heat shrink and the screwdrivers for the little connections and terminals, couplers for Bowden, screws, etc. So we'll unpackage that in a sec. And also, very importantly, they include labels for the pinouts so that you can keep track of what wire goes to what pinout number here. The pinouts also have different amperages or amperage ratings, so you need to be cognizant of that. These two over here are 10 amp, I believe. Let me just refer to the things here. Yeah, 10 amp, you have 2 10 amp. So we would use that for a heater cartridge, though that's super overkill for the heater cartridge. And then all of these are maximum of 3 amps output. So if you're on a 24 volt systems, volts times amps equals watts. So if you have 3 amps, 24 volts, you're looking at about 72 watts of power that you could draw through here. So as long as your heater cartridge is under 72 watts, you should be perfectly fine using any of the 3 amp pins, but just for a lot of buffer and safety, and you know, you only have one heater cartridge, then I would just suggest using the higher amperage pins for that. So with that rant aside, we also have 3 more bags, one for each of the mobile plates. So this is an accessory bag for each of these, which includes screws and nuts to mount your stuff to that plate, wire loom, a couple spacers, heat shrink, zip ties, and again, label stickers for your connections. There's also a package here that has a belt in it, a GT2 belt. I suppose if you wanted to change the X belt while you're at it, you could use that to do so. And then the optional kind of accessories, like I said, depending on what kind of printer you're mounting this to, we have 3 different X carriage mounting plates. So there's the linear rail, there's a universal roller, and then there's the HPI 50K, it says. So let's do that one last. What we're going to be interested in is the universal roller, right? So this is using your standard V rollers, and to many of you, this probably looks familiar. So, you know, the belt connects into these teeth here. We're going to mount this stationary plate onto here like that. So it's obviously got a bolt pattern specific to this guy, so it bolts right on. And then we would use the V wheels here and all the associated bits for that to bolt through here and attach those wheels to this new bracket. Right? So this basically removes your need to print your own kind of adapter plate to take whatever holes you have in your X carriage and make them line up to this guy. That's definitely another option as well. Within that box, there's also additional screws in case you can't use the original ones because the bracket's too thick and all kinds of accessories you'll need to mount that. So the other one here, linear. So this is if you have a linear rail. So this would go on the block on the linear rail, and it has the mounting hole spacing appropriate for those. And again, mounting accessories, screws, belt, etc. So I was wrong. The third box is not another universal bracket. This is a collection of heat inserts, so threaded inserts that you heat with a soldering iron. And there's actually a tip here that you could place into a soldering iron if your iron was compatible with this guy. But this would be primarily if you were printing your own brackets and wanted to melt in your own threaded inserts. In the case of these, there's like square slots on the back to kind of capture the nuts in, stop them from spinning, and we'll just screw into those nuts. So we're not going to need that for today's demonstration. All right, so the first thing we're going to do is unbolt everything from the X carriage here, and we're going to reuse the bolts and bearings and wheels and everything, except in the case of the top two bolts. These bolts here aren't like countersunk, so they won't sit flush. So they include in the kit two countersunk or tapered head, flat head bolts that will sit completely flush with this bracket. Obviously, these instructions will be a little bit different depending on what printer you're working on, but take off the shroud and unbolt everything. All right, so with the shroud off here, you can see the part cooling fan is these blue and yellow wires. There's not a whole lot of slack there. We're gonna have to cut off this zip tie. And then we're gonna unbolt the hot end itself from the carriage. And during all of this, leave the wires connected. Don't do anything with the wires yet until the next step. So with the hot end out of the way, and I've snipped the zip ties so we can expose these wires in the next step there. But with all that out of the way, we now just need to take out these three bolts, and you're obviously going to need a wrench to hold onto the nut while you do that. When you are taking these bolts out, you want to make sure that you keep track of all the parts involved and the order in which they came off, and then therefore you're going to put back on the printer. So we have the nut on the back of the top one here, and then there's the wheel, and then there's the aluminum spacer. Okay, so the spacer is going to have to go back between the backing plate and the wheel. Now, depending on your printer, you could have multiple different spacers or little washers or lock washers. And on the bottom here, we kind of have that situation. We have the nut on the front, and then we have a washer here. And then if we pop this out the back, we then have the eccentric nut instead of just a standard spacer, then the wheel, and obviously the bolt through all that. Okay, so keep track of that. Now, we're not going to use this plate. As we said, we're going to replace it with the Wham Bam plate. And the belt here, we might be best suited to reduce the tension on the X belt. There. We would be best suited to reduce the tension on the X belt to give us some slack. And then we should just be able to slide this off the fingers like that. Now, the finger spacing on this is actually different than the original bracket. So you can either reuse the existing belt, and you would just have to use a zip tie to kind of make the appropriate amount of tension, because it's likely not going to sit with these little ferrules pinched on there. It's likely going to have extra slack in the belt, so you would have to double it over and zip tie it like that, so that it's decently taut. And then you would use your X belt tension assembly on the far right side there to properly tension the belt further. Or we can just go ahead and completely replace that belt with a brand new one, which is what I'm going to do today. So to take this belt off, it's probably easiest if I remove this shroud. The screw holes are actually behind the sticker here, and they bolt right through the X-axis stepper motor. I'm not going to do that because I can kind of see through the port here and get access. On this side though, I will remove this entire cover assembly to get better access to the smooth bearing underneath there. So now I've got this cover removed here, and we can just pull the belt through and out. If we're lucky, we may have to actually remove the entire tension mechanism here. There we go. All right. And then here. Good. Let's take our new belt. And we'll just feed it exactly back the way we just pulled it out. So now that I've routed the belt through that path, and I've just left the excess kind of laying there, I haven't tensioned the tensioner at all, just enough to kind of get the nut on the end here. And obviously your tensioner assembly might be a little bit different than that. But now we're ready to attach this plate to that rail with the wheels and bolts. So the eccentric nut has this round section here, the skinny round section, and we want to make sure that that goes through, through the backside, but that goes through and sits inside the hole of the bottom hole here, right? So that's flush. And then we'll put the washer and the nut. Okay, so now we're going to take those bolts from the package, slide them through there, and then assemble it in the reverse direction. So we're gonna add the spacer, wheel, and then there's no washer or anything, there's just the lock nuts on the back. Now you gotta leave this super loose if you're doing it off the machine, otherwise you won't actually be able to slide it on. The last wheel I'll actually assemble completely on the machine, just to make sure, whoop, wrong bolt, just to make sure that I can get it on. Okay, we're gonna take 2 of the zip ties and we're going to zip tie the belts now. So worth mentioning is that eccentric nut at the bottom, I have tightened it so that there's no slop in the plate, and then when you spin the wheel, there's no slip in any of the wheels, you know, top or bottom. Everything's good, no binding or anything. So that's done. We're gonna attach the belt here. And the easiest way to do it is obviously teeth up and then double it back on itself like that. And then you're gonna zip tie right around here to kind of tighten that up and make sure that it stays on the tooth. So I've attached the belt here with a zip tie. There's 2 different ways that you could route this belt. You could route it over the top and then under. But if you do that, the 2 smooth sides of the belt will be pressing against each other. And since we're really only locking them together with a zip tie here, having the teeth intermesh like this really reduces the chance of this belt slipping at any point in time. It's a much more secure connection, even though the belt path is a little bit more angular than it would have been if we went over the top. But with that said, we've now got one attached, and we're going to do the same thing with the other side here, route it over top, and then intermesh the teeth like that. So now that I just mentioned about intermeshing the teeth, on this side, we actually can't do that. If we have it routed, on the bottom like that so the teeth can intermesh, this angle here causes a problem and causes it to bind over here as it kind of starts rubbing up against this plastic casing here and the screw underneath it. So to make sure that that is as straight a path as possible, it has to go over the top so that there's no binding there, which means that we're going to have the 2 smooth sides like that with a zip tie squishing them together. Okay. So now the fixed plate here is going to get mounted into these 4 locations with M3 bolts that are included in the accessories bag. On the left side here, we're going to use M3 by 6 millimeter long, and on this side they're M3 by 16 millimeters long. So now what we need to do is identify where we would cut these wires. You can use a Sharpie to kind of draw a line across them. When we cut them, part of it is going to go into this top piece where it'll terminate in there. And then the slack that we have on this end needs to be able to connect into the top of the plate that they're screwed onto. So you don't need a whole lot on that side, just maybe an inch or 2 from the top of the hot end assembly, not an inch or 2 total of wire. So in this case, somewhere around here should be adequate slack for all the bits. So I'm going to draw a line across here and cut. Now before I cut though, we're going to label on either side of the line that I draw here, we're going to label each of these wires with this sticker set. So the idea is that red are positive, gray are negative or ground, and some wires don't actually have a polarity where it doesn't matter. So the 2 thick ones here, your heater cartridge, it doesn't matter which is which. So honestly, they don't really need to be labeled. And they are going to go to the A and B terminals over here. These 2 white ones are the thermistor cartridge. Again, there's no polarity on those. The blue and yellow, as we talked about before, is the part cooling fan. There is a polarity there. and they're not color-coded nicely like this one, so we'll have to figure out which one's positive and negative. But then the hot end cooling fan is black and red, positive and negative. So you would label them with the appropriate sticker, both color and letter that corresponds to the letter on these blocks here, so that you can kind of keep everything straight. You know, if the heater cartridge is A and B here, then inside here it needs to also go to A and B, obviously. Now this piece here, ideally, you know, I could take this and kind of mount it right there. Unfortunately, the hole spacings don't line up, so we are going to have to print some sort of a bracket here to hold the part cooling fan at the right angle and everything, hold the hot end, you know, the cold side, bolt that on there with a little bit of a spacer so that the hot bits aren't sitting right up against here, melting the plastic bracket. So we will have to come back after a couple hours with one of those adapter plates or brackets printed up. But for now, we can, like I said, leave a couple inches, cut and label these, and then we'll be back to start connecting them into the fixed side of the bracket. So as I mentioned earlier, the removable plate here has a bunch of slots where you can put the nuts in the back and bolt your hot end and cooling fans and everything to here. We're going to try to reuse as much of the stock setup here as possible. Obviously, we could have printed an elaborate mount to have different cooling fans and everything to bolt onto here. I know Hero Me has a version that mounts onto this back plate. But another option is to print these little adapter brackets that will allow us to bolt this shroud assembly to this plate. You know, there are two threaded inserts here, and my hope was to be able to bolt through the back like that. Unfortunately, number one, these little tabs cause a bit of a gap spacing issue, but also those two little threaded inserts don't line up with any of the holes on here. At least not in a way that keeps this like perfectly, you know, horizontal or vertical, depending on your perspective. So these little adapter brackets, I'll link to the Thingiverse link for these. They bolt onto the back of here, and then they give you a very tidy mounting option onto here. So there is a left and a right of these, and the easiest way to determine which is which is there's these little like rectangular voids or notches in them. There's two voids on one and one on the other. And on the back of the shroud, there's these two notches on one side and one on the other, right? So the one with one notch, you align the notch, so this is upright like that. So if we flip it around, align the one notch with that little tab, and the recess there lines up with the threaded insert on there, and we'll use an M3 screw through the back there to attach that. And we'll do the same on the other side with two notches, and in a similar fashion, it has a recessed section for the M3 bolt. Then that gives us two bolts up top to mount it onto that removable back plate. So I'll attach this to the fan shroud, and we'll come right back. All right, I've got it attached. So there's the two screws in the back there. And so now on the front, there are 1, 2, and 3 exposed bolt holes. We'll just talk about the top two first. So those top two bolts there are going to bolt through those holes right there. And so on the back side, we're gonna put one of these square nuts in the back, and we'll use M3 screws through there like that. Before we do that though, we need to mount the hot end in there and then put this guy over top. So in the package from Wham Bam, there are a couple different spacers. So these are the two spacers here. This spacer lines up perfectly with those holes. So the stock screws should be long enough. If not, you might need slightly longer M3 screws. And they bolt in through the front, through the spacer, through the back here, and into the square nuts on the back. Now, the mount here, like I said, is those top two holes. So it's either going to be this set of slots or this set of slots, depending on how far down we need this to be. Probably the second set of slots. And if we kind of, you know, roughly hold everything up the way it would be installed, lining it up with the holes, you can kind of see how far down the hot end needs to be, you know, right there, and figure out that yes, it's this second set of slots here that it's going to go into, okay? So like I said, square nuts in the back, bolt through the front, and use that spacer on the hot end here, like that. So I'll bolt the hot end on first, and we'll come right back. Okay, so I used the spacer. The kit came with longer M3 screws that fit perfectly and is bolted through the back there. And it's kind of, centered as best as possible. And then this guy here goes over top. I'll do the same thing through those top two bolt holes there. Yeah, those two. And if you wanted to, this one down here also aligns with one more hole down on this side, so you could bolt in through there also. And then I'm gonna cut the wires, connect them to the terminals up here, and connect the other side of the wires inside here to match the pins on top there. All right, so I've screwed those 3 screws in on the back. Looks good. The nozzle sticks down far enough to clear the fan shroud, so that's important. And dovetail slides in there. So now we get to cut our wires. So holding this back here with like a zip tie is pretty handy to keep it out of our way. Tape obviously also works. Okay, keep that back there. And so there are labels on the back here, letters AB on here. As we mentioned, that's the higher amperage one. We're gonna use that for the heater cartridge. And then C through T on here. And under the cover on the fixed side of the plate, there are corresponding terminals under there. So let's open up that. There's just 3 small, these are probably like M2s, really small screws here. So you got to remove the 4 screws to get this cover off. And there's a row of connectors right here that have the same labels, C through T, as on the removable plate. And then our heater cartridge under here. So, as I'm sure I mentioned earlier on, the wires, some of them have polarities. So there's a positive and a negative, and that is important to keep those straight. Others, like the heater cartridge, it doesn't matter. So the heater cartridge is obviously these 2 thicker ones here, and you can trace them down to see where they go. So these are the heater cartridge. These 2 white ones are the thermistor. Like the heater cartridge, the polarity doesn't matter on the thermistor. And then we have 2 fans. So the black and red, in this case, are the hot end cooling fan here, and the blue and yellow are the part cooling fan. Okay. Black and red, standard color scheme. Black would be ground, red would be positive, right? So positive and negative, if you will. The blue and yellow, I believe the blue is the ground, the yellow is the positive. This, if we're not swapping components onto here, this isn't that important. What's important is that if blue goes into D, then blue on the removable plate goes into D as well, right? So those need to line up. But in the future, if we swapped out one of these fans and we suddenly have black and red, and on this side we have the original blue and yellow, well, which one goes to which, right? So that's where positive and negative is important to understand which is which to line up your new components. They do have labels for everything, so you can label both sides of the wire, attach little stickers to them so that you can keep track of where they go. I'm gonna forego the labels in my case, but definitely if that's helpful to you to keep track of everything as you're working, please make use of those. The printer is off, of course. I wouldn't be cutting any wires if the printer was still powered on. And I'm gonna start with the easiest ones first. We're gonna cut the heater wires. So the way I would suggest we do this is let's attach this guy back on here, and we need to leave ourselves enough slack that it can reach the removable side of the plate, like right there, right? That gives us some slack here still, maybe right about there. Cut those. Okay. And the side that's attached to the printer is going to the stationary part under that cover that we just removed, right? And so now we'll strip these and we'll screw them into the connectors Again, A, B, doesn't matter, no polarity on the heater cartridge. So I went a little bit ahead of myself. I got the heater cartridge and the thermistor done. So thermistor is the white ones in C and D. I just want to take a second to kind of save you from doing the mistake that I almost did. I mentioned, cut them to make sure that there's enough length to reach the terminals here. And so I looked at the front of the terminals and I said, yep, there's plenty of length to reach the front there, and I cut them. And I cut them too short. They go in the back, not in the front. So you kind of have to hook them around the back, which requires a little extra length. So I managed to make it work with the thermistor wires, but it was tight. Another thing is the stripped portion of the wire, just make sure you kind of twist those strands that are inside there, because as we're inserting it into the block here, we don't want an errand strand to kind of touch another wire near it, or vice versa, or two strands. So just kind of twist them, make sure that they go all in the hole directly, and then tighten down the clamp on them with the screw there. So they're installed, but it was almost a disaster. Not a big deal. You just have to replace the thermistor, which on this one is probably a bead thermistor, and cut them at the proper length this time, right? But I don't want to have to disassemble this right now that I just got it put together. I've also cut the fan wires. So we have the blue and yellow again, that's the part cooling fan, and black and red for the hot end cooling fan. And I've made sure that they are plenty long enough to wrap around. So I'm going to use the next two terminals here for black and red on both sides, and then I'll do blue and yellow in the same order on both sides. All right, so we are done. All the colors line up, so everything's connected well. I've double checked to make sure there are no strands, as I mentioned, because that's a definite risk, and I don't want to be blowing a board or any other components. So now I'm going to cut off the zip tie that was just kind of holding back the braided sleeving here. And there's a nice little vertical standoff piece back here where it's meant to kind of align your wiring with. So there's a groove in this vertical standoff piece for a zip tie to go and kind of attach the wire loom there to that bracket just for support so that we're not pulling on the wire connections themselves. And you don't want to go crazy with zip ties. I mean, I've seen it before where people have tightened the zip tie to the point of actually breaking the wire. They've really reefed on it. Especially some of these tiny wires like the thermistor. There's only a few conductors in there, and it's very, very easy to damage that. So we're not going crazy, but the standard back and forth is not going to be tugging on the terminal connections. That's really mission accomplished. That's enough, right? Okay, so then we can reattach this top cover here. It goes here. And silly me, to do that, this has to be off. There we go, that makes a lot more sense. There. And really small M2s. The cover really cleans up the look of it, I actually almost wish there was a cover on this side too. But really, what's the saying? Function before form, right? Cool. So now if I wanted to have a different hot end assembly, I may need, I'll have another one of these plates. I may need a different adapter or mounting bracket of sorts, but it would be very trivial to then swap this one out, swap my other one in, and be back up and running, Especially if you're running this in a, like a production type of environment, time's money. For me to disassemble a hot end and repair a clog or replace, I don't know, a worn out component, or if the collar here has the teeth are not grabbing the Bowden tube anymore and holding it securely, and I have to remove that collar, I gotta take all this off. I would do that, but it would be a lot quicker if I could just pop it off the machine like this, detach the Bowden tube maybe from here, because this is a PTFE hot end, it goes right down to the bottom. That's not gonna come out very easily. And then plop a new one back on and I'm up and running in 30 seconds or so, right? Then I can do maintenance on the hot end off the printer at my leisure, right? And my printer is back up and functional. So there's definite use cases. I have an army of BIQ B1s right now, and I have spare hot ends specifically for that reason, to just go swap, put a new one on, and then worry about what I have to replace, a worn out fan or what have you, right? So that's really nice. Let's turn it on and make sure that everything still works. Well, we haven't let out the magic smoke yet. So we don't need to worry about the motion because we haven't affected any of that. I can see on the screen here that the hot end is reading about 26 degrees ambient, the bed 25. So that's good. That's a sign that the thermistor is actually working. If the thermistor wire is disconnected or the thermistor is otherwise not working, you'll usually see like a very bizarre temperature, like -10 or -15 or some weirdness like that. We're seeing, room temperature. If you hold your finger on the nozzle for a little while or right on the heater block by the thermistor, the temperature should rise, and well, it went up a degree there anyway. So I know that's working. We can obviously, let's preheat the hot end here. So I will go to control. I'm not familiar with this UI that much. Nozzle temperature, set it to 190. Let's also check the fans. So I'm gonna go to fan speed, turn the fan on full. There we go. Cooling fan is on. Cooling fan is off. And most important, the hot end fan is running all the time here. So that's good. Mission accomplished. All of our connections are working. They're connected to the appropriate counterpart under there. And like I said, if you are swapping it with a hot end with a different color coordination, you're going to need to make sure that you have positive to positive, negative to negative. Don't just blindly line up the colors unless it's exactly the same as we have here. But that's it. So the only thing left to do is figure out if it still prints as well as it did before. We have changed a lot of things. You got to make sure that the hot end is perfectly vertical. If you've installed it cockeyed at all, that can cause some issues. Specifically, if it was rotated like this at all, this fan duct would hit the bed before your nozzle does. That's obviously never going to work. And because of the nature of the slots that we bolted the hot end through, we don't have like infinite vertical flexibility. If those slots were vertical with that spacing, then we could slide it up 1 millimeter or down 1 millimeter as required. We have zero flexibility in those slots. So if there was any, the hot end is hot now. If there was any, tolerance issues in your printed bracket or even design flaws in the spacing and sizing of that bracket, your shroud assembly and everything could be not in the best position with respect to the nozzle position. So I've already made sure I lowered it, made sure that the nozzle touches and everything else clears. So we'll do a couple, rudimentary test prints, just confirm that everything's working still, that the print quality is still as good as we had before. We're not going to see an improvement in any of that, but we need to make sure that we haven't introduced any kind of problems that didn't previously exist. So that's a lot of words. Let's just go get printing, and then we'll come back and show you the result. All right, we're back. So a couple days later, but in my absence, the guys at the shop printed another one of these. And I understand that they printed one of these the other day on like the little Maker Pi we were checking out. But we were just printing something that we had sliced on file to prove that it still prints just as good as it did before. So we didn't mess anything up. Because we weren't really changing anything around the hot end, we're not expecting any quality differences here. The key thing is to make sure that it functions just as good as before. We haven't introduced any slop anywhere. We made sure to tension our wheels appropriately so the hot end is riding true on that rail. I'm happy with the end result. And now we have the ability to swap out our hot ends much, much easier than before. So hopefully you found that useful, kind of a cool new gadget on the market. Remember to like and subscribe and ring the bell to get notified when we upload more content like this. Thanks for watching.